Hello students, we are going to study the chapter circle. Circle, what is the basic definition? Circle is locus of points, that is a collection of points which are at a given fixed distance, points which are at a given fixed distance from a given fixed point in the plane, right? This is a circle. This is a locus of points. It is a given fixed point. It is a given fixed distance. And these all points constitute a circle. That fixed point is called center of circle, and given fixed distance is called radius of circle. Generally denoted by R. It is always positive, right? So circle is a locus of points, a collection of points, a set of points. What type of point? Which are at a given fixed distance. A certain distance is given to you at a given fixed distance from a fixed point. There is a fixed point in the plane. So this is a circle. That fixed point is called center of a circle. Fixed distance is called radius of circle. Radius is always positive. Now we shall turn to the types of circles, that is standard circle is said here. A circle whose center is origin, then a circle is called standard circle, right? Observe here, whose center is origin. Right? If a radius equal to a, if we take the radius equal to a, then its equation become x square, that is x minus 0 bracket square plus y minus 0 bracket square is equal to a square. Distance formula, that is x square plus y square is equal to a square. Using distance formula, simple, pxy be any point on the circle. So x minus 0 bracket square plus y minus 0 bracket square is equal to a square. So x square plus y square equal to a square. Parametric equation of theta, that is theta is OP makes an angle theta with a positive direction of x-axis, right? Theta. That's it. Then with the help of that, by definition, x equal to a cos theta and y is equal to a sin theta. X is equal by definition distance of that point from the origin a and cos theta. So x equal to a cos theta and y is equal to a sin theta. General circle. What is a general circle? A circle whose center is not origin is called general circle. Here I have shown that is a general circle. Center is HK, radius equal to R. So its equation can also be written x minus h bracket square plus y minus k bracket square is equal to R square. Simple distance formula, and this form where HK is a center and R is equal to radius, the form of equation of circle is called center radius form. What is called? Center radius form. X minus h bracket square plus y minus k bracket square is equal to R square. HK is a center. Fourth one, parametric equation of general circle. There is a parametric equation of standard circle. X equal to radius a cos theta, y is equal to radius sine theta. So parametric equation of general circle. X is equal to, only just add hk is the center, x equal to h plus r cos theta, and y is equal to k plus r sine theta. X equal to h plus r cos theta and y is equal to k plus r sine theta. So this is the parametric equation of general circle. Now listen here, another form. So this is one general circle whose form is known as a center radius form, very important form. Then parametric equation. Then parametric equation is x equal to h plus r cos theta and y is equal to k plus r sine theta. Now if a x1 y1 and b x2 y2 are endpoints of a diameter AB, here I show the diameter AB, so its equation can directly be written as, that is called a diameter form. Only I have taken that is x minus, that is x minus x1 into x1 plus x2, x minus x2, sorry, x minus x1 to x minus x2, x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. That is form is known as the diameter form of circle. Again, ax1 y1 and bx2 y2 are endpoints of a given diameter of a circle. Then the equation of circle with the help of the diameter can be written as x minus x1, x minus x2 product plus y minus y1 into y minus y2 is equal to 0. So one is there, center radius form, other is there, parametric form. This is also known as a diameter form of the circle. Next, proceed. General equation of circle. Consider x minus h bracket square, y minus k bracket square is equal to r square. This is what? That is center radius form. Simplify. Center radius form, x square minus 2hx plus h square plus y square minus 2ky plus k square minus r square is equal to 0. Simply I have simplified, making square and r square transferring on this. Collecting the term, x square is equal to x square plus y square minus 2hx minus 2ky plus into bracket h square plus k square minus r square is equal to 0. Observe the equation. What do you observe? It is a general equation of degree to n x and y. It contains the two variable x and y. General equation, x square, x and constant, y square, y and constant. That is called general circle. Only x square, y square. It's a homogeneous equation. It's a homogeneous equation. So therefore, there is no term xy. No term of xy is present in the equation of circle, and coefficient of x square is equal to coefficient of y square. Coefficient of x square is equal to coefficient of y square. Observe this. Only I have taken the center radius form. I have simplified and I am observing the behavior of the equation of the circle. So I come to know that coefficient of x square is equal to coefficient of y square. 1, 2. There is no term in xy, no x and y, xy. And it is a general equation of degree 2 in x and y, right? Any equation satisfying this condition always represents a circle, any condition. So I'm using this condition. Coefficient of x square equal to coefficient of y square. Capital X square plus capital A y square. Coefficient of x square equal to coefficient of y square. No term in xy. Plus 2gx plus 2fy plus c is equal to 0. Dividing both sides by a, because capital A is not equal to 0. So we get x square plus y square plus 2 capital G upon A into x plus 2 capital F upon A into y plus capital C upon A is equal to 0. Only I divided by A. Now that G upon A is taken as a small g, that F upon A taken as a small f, and capital C upon A is taken as a small c. So the equation become x square plus y square plus 2gx plus 2fy plus c is equal to 0. So this is called general equation of circle. X square plus y square plus 2gx plus 2fy plus c is equal to 0. Remember, comparing with the center radius form, if we continue, we get directly the center is always minus g minus f, half the coefficient of x and opposite, half the coefficient of x and opposite x coordinate, and half the coefficient of y and opposite half the coefficient of y and opposite, that is a center, minus g minus f, and radius r is equal to root of g square plus f square minus c. This is a radius. So remember that the general equation, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then the center is minus g minus f, and radius is root of g square plus f square minus c. Remember that coefficient of x square and coefficient of y square must be 1 in that case. If it is given to you that 5x square plus 5y square, coefficient of x square, coefficient of y square, both are same, right? So it represents a circle. But while finding the center and radius, first what to do? Divide the x square y square, that is 5 is there, dividing both sides by 5. So whatever we get, that is a coefficient of x is g, small g, coefficient of y is f, etc. So this is said, that is general equation, x square plus y square plus 2gx plus 2fy plus c equal to 0, and its center is minus g minus f, and radius equal to root of g square plus f square minus c. See the different forms of the circle. This is a circle, center lies on x-axis, so of course y 0, that means y coordinate of center becomes a 0, so minus g 0 is the center, and in that case radius become root of g square plus f square, but there is no f, g square minus c. If center lies on the y-axis, remember that becomes center, x is 0, y is minus f, 0 minus f, and radius equal to root of only f square minus c, right? Here, circle touches x-axis. Circle touches x-axis. Remember that circle touches x-axis. It's a y coordinate. It may be any direction. So mod of y coordinate of center is always a radius. This becomes a radius. Remember that. Mod of y coordinate of center becomes a radius, right? If circle touches y-axis, remember that this is the x coordinate of center. So, but it may lies in any coordinate. Radius is always positive. So that mod of x coordinate of center, mod of x coordinate of center is equal to radius, mod of. Circle may be in any coordinate. And when circle touches both the axes, in that case, x coordinate and y coordinate of center both are same. 2, 2, minus 2, minus 2, 2 minus 2, minus 2, 2, like this. 4 such circles are possible there. Circle touches both axes. So mod of x coordinate same, a mod of y coordinate same. This is a radius. So mod of x coordinate of center is equal to mod of y coordinate of center is equal to radius in that case. Remember that if 2, 2 is there, mod of 2, 2 is a radius. If circle lies in the third quadrant, its coordinate minus 2, minus 2, but radius equal to 2, mod of minus 2. If circle lies in the fourth quadrant, its center is 2 minus 2, but radius equal to 2. If circle lies in second quadrant, its center is minus 2, 2, but radius equal to 2. Radius is same. So this is a type of the function that means center lies on the x-axis, y-axis, circle touches the x-axis, mod of y coordinate is a radius, circle touches y-axis, mod of x coordinate is a center, circle touches both the axis. Remember that mod of x coordinate is equal to mod of y coordinate, both are same there, radius is positive. Correct? Yes. So this is typical type. Then equation of chord. What is the chord now? A x1 y1 b x2 y2 are given two distinct points on the circle. So first of all, equation of chord, standard circle. It is a standard circle. So equation of chord AB. Remember, x minus x1 into x1 plus x2, x minus x1 into x1 plus x2 plus y minus y1 into y1 plus y2 is equal to 0. Again, x minus x1 into x1 plus x2 plus y minus y1 into y1 plus y2 is equal to 0. Equation of chord. Correct? Right. Further, it is equation for standard circle and equation of tangent. Correct. At this point, at the point, correct. What is the equation of circle? Equation of tangent to the circle at x1 y1, standard circle, x square plus y square is equal to a square. Tangent. Only do at the point, that point should be on the circle. Then the equation. Only replace x square by xx1, y square by y1. If 2gx is there, half the g write down into bracket x plus x1. 2f is there, half, that means remove the 2, f into bracket y plus y1. No change in c. That is become equation of tangent at the point, that is. So equation of tangent denoted by t is equal to x square as xx1 plus y by 1, transfer a square on this side minus a square is equal to 0. Remember like this. Similarly, equation of tangent to the circle, x square plus y square is equal to a square from the point p x1 y1 given outside the circle. Outside the circle is given there, point outside the circle. We shall see that last, how to determine the position of the point with respect to circle. Okay, equation of tangent drawn from the point P. Here I showed two tangents can be drawn outside the point P x1 y1 in terms of slope m. Y is equal to mx plus c. It is an equation of line in terms of slope m, not at the point, that is from the point, and c is equal to the value plus or minus root of a square m square plus a square. Try to write like this actually. If you can take the a square common also, so c is equal to plus or minus a root of m square plus 1. This is called, that is called condition of tangency. What is called condition of tangency? Any line y is equal to mx plus c is a tangent to standard circle if c is equal to plus or minus root of a square m square plus a square. If you want to take the a square common, a root of m square plus 1. It is called condition of tangency. That means a line is given to you, say 2x plus 3y plus 4 is equal to 0. Show that it is a tangent to the circle x square plus y square is equal to 16. So what is your a square? 16. Well, when you write the 2x plus 3y is equal to 5, write the equation in such a form, y is equal to mx plus c, slope intercept form. Find out the coefficient of x, m, and finally c. Right, c is equal to plus or minus root of a square m square plus b square. For the sake of convenience, do the calculation. C square is equal to a square m square plus b square. Substitute the value of c there, m there, a there. If it is, then it's a tangent. Right? So we shall see later. And where it is a tangent, the point of contact, that is called where tangent touches the point. This is the point of contact. How to go in? Minus a square m upon c comma a square upon c, minus a square m upon c comma a square upon c. That is for all, for the standard circle. What is the equation of the standard circle? X square plus y square is equal to a square. What is the equation? Listen here, listen carefully. Yes. X square plus y square is equal to a square. What is the equation of chord? Equation of chord is that x minus x1 into x1 plus x2 plus y plus y1 into y1 plus y2 is equal to 0 is the equation of chord. What is the equation of tangent? At the point, that means on the circle point x1, y1 is given. Replace x square by xx1, replace y square by y by 1. If there is no other term, constant remain as it is. So equation of tangent, t is denoted by this xx1 plus y by 1 minus a square equal to 0. Equation of tangent to the circle x square plus y square equal to a square from the point P x1 y1 given outside the circle, not on the circle. Y is equal to mx plus c. Y is equal to mx plus c. C is equal to plus or minus root of a square m square plus b square. Condition of tangents. If the condition is satisfied, it is a tangent where it means minus a square m upon c comma a square upon c. This is point of contact. Okay. That is equation of normal for the standards. What is the normal? X upon x1 is equal to y upon y1. Finish. X upon x1 is equal to y upon y1. It is a line always passing through origin. What is a normal? Normal is a line. Just wait. Yes. See. It is a circle. It is a tangent at the point. Then the line perpendicular to tangent is called normal. And its equation for the standard circle is very easy. X upon x1 is equal to y upon y1. It is a line, always that normal passes through that origin. Always passes through the center of a circle. Now for the general circles. Is it okay for the standard circle? What is the standard circle? Chord's equation is what? X minus x1, x1 plus x2. Yes, plus y minus y1, y1 plus y2 is equal to 0. Equation of tangent, x square, x square, y square, y1. See as it is. Condition of tangency, C is equal to plus or minus root of a square m square plus a square, or a into root of m square plus 1. Okay, turn to for the general circle. Equation of chord whose endpoints are ax1 y1 and bx2 y2. Only change is what? In the standard circle, x minus x1 into x1 plus x2. Here, x minus x1 into bracket x1 plus x2 plus 2g. x1 plus x2 plus 2g plus y into y minus y1 into bracket y1 plus y2 plus 2f. y1 plus y2 plus 2f is equal to 0, right? So this is equation of chord ax1 y1 and bx2 y2. Equation of tangent, what I note? Add to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Add the px1 y1, add. Given point of the circle. Replace x square by xx1. Replace y square by y1 plus make the half g into bracket x plus x plus half y if into bracket y plus y plus c is equal to 0. You can use this concept, you can use this trick for any type of curve, any type. Known curve, unknown curve only. X square, x square, y square, y. X is there, make the coefficient of x half and in the bracket x plus x1. Make the coefficient of y half in the bracket y plus y1. Constant as it is. Replace x square by x1, y square by y1. That is at the point, correct? Yes. And therefore tangent T xx1 plus y1 plus g into bracket x plus x1 plus f into bracket y plus y1 plus c is equal to 0. The general equation, that is for the general circle, this is equation of tangent. Now for the general circle, there is not a condition of tangency. There is no condition of tangency, right? To show a given line is a tangent to the general circle. A line is given to you. I am giving the step 1. What to do? Given line y is equal to mx plus c. That is mx minus y plus c is equal to 0. Line. Write it. Second step. Draw perpendicular from center on the line mx minus y plus c equal to 0. From center is no, when the equation of circle is given, that means center is given. So mx minus y plus c equal to 0. Draw perpendicular. If the distance so obtained, perpendicular distance, is equal to radius of circle, the line is tangent to the circle. And to find the point of contact, solving equation of line and circle, point of contact can be obtained. Take a line, write a line ax plus by plus c equal to 0. From center, draw the perpendicular. We have the formula for the perpendicular. ax1 plus by1 plus c upon root of a square plus b square. This is a perpendicular distance formula that we can use here. We shall show the example there, right? So this is. So for the general circle, there is no condition. We have to do it, right? First you write the line, draw the perpendicular from the center. If length of the perpendicular is equal to radius, it becomes a tangent. Otherwise, no. That equation of normal at px1 y1 to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. center is minus g minus f, and radius root of g square plus f square minus c is x minus x1 upon x1 plus g. X minus x1 upon x1 plus g is equal to y minus y1 upon y1 plus f. Y minus y1 upon y1 plus f. This is equation of normal at that point, correct? So, madam say it. Continue, Guru. Find the locus of point of intersection of the tangents whose inclinations are alpha and beta. Now, a point is given outside the circle. From that point, two tangents are drawn. The inclinations of these tangents are alpha and beta. That means tan alpha and tan beta are slopes of these two lines. Let tan alpha is equal to m1 and tan beta is equal to m2. These two are there. So find the locus. Some locus I have taken here. This is common for, or that is for the circle, parabola, ellipse, hyperbola. Then also we can do it. Now listen here. So locus of point form where tangent drawn to the circle are at right angle to the circle, x square plus y square equal to a square. Standard circle I have taken, so I can use the condition of tangency. Let equation of tangent drawn from point P x1 y1 and given outside the circle this point in terms of slope m, y is equal to mx plus c, where c is equal to plus or minus root of a square m square plus a square, right, like as it is, or a root of m square plus 1. Y is equal to mx plus or minus root of a square m square plus a square. That is mx minus y is equal to plus or minus root of a square m square plus a square. Squaring both sides. So remove the root, squaring m square x1 square minus 2m x1 y1 plus y1 square is equal to a square m square plus a square. Why I have substituted x1 y1? Because x1 y1 satisfy the equation, because tangent is drawn through that point, therefore coordinates satisfy the equation. Simplify, correct, and this equation write in such a form that is comparing x1 square minus a square into m square, collecting the terms of m square together, minus 2x1 y1 m plus y1 square minus a square equal to 0. This is a quadratic in m. I am arranging that m square minus 2x1 y1 upon x1 square minus a square into m plus y1 square minus a square upon x1 square minus a square equal to 0. I have arranged that it is a quadratic equation in m whose roots are m1 and m2, which are slopes of the tangents drawn through px1 y1. The tangent which we have drawn through point px1 y1, the slopes of these tangents are given by this quadratic equation, that is m square minus 2x1 y1 upon x1 square minus a square plus y1 square minus a square upon x1 square minus a square equal to 0. Comparing with the standard form of quadratic equation, m square minus sum of the roots into m plus product of the root is equal to 0. I get m1 plus m2 is equal to minus minus, comparing with this 2x1 y1 upon x1 square minus a square, m1 m2 is equal to y1 square minus a square upon x1 square minus a square. This is a main basic, that is for circle, parabola, ellipse, hyperbola, this type of all this. I am going to stress you, that is only condition changes, only C changes. C is equal to A upon M for parabola. C is equal to root of A square M square plus B square only for the ellipse. C is equal to plus or minus root of A square M square minus B square for the hyperbola. Only C changes. So what we had? So only this part is here changes, nothing here. Y1 square plus B square upon x1 square minus A square, right? For the hyperbola, y1 square minus b square upon x1 square minus a. P comes over there, P. Only that is a change. And that is the value m1 plus m2. And then whatever the condition they are given, we can solve this. Alpha and beta are inclination of tangent drawn through px1 y1. So therefore slope of these two tangents, m1 is equal to tan alpha, and m2 is equal to tan beta, right? Now, what is the first condition of the locus? Tan theta 1 plus tan theta 2 is equal to k. So, m1 plus m2 is equal to k. What is m1 plus m2? We have compared there. Value of the m1, 2x1 y1 upon x1 square minus a square is equal to k. So 2x1 y1 is equal to k into bracket x1 square minus a square condition. So required locus is replace x1 y1 by xy, 2xy is equal to k into bracket x square minus a square. Correct? What's the second locus? Tan theta 1 minus tan theta 2 is equal to c. m1 minus m2 is equal to c. I don't have the value of m1 minus m2. I'm going to find the value of m1 minus m2 with the help of m1 plus m2 and m1 m2. How? m1 minus m2 bracket square is equal to m1 plus m2 bracket square minus 4 m1 m2 that we have. m1 square plus 2 m1 m2 plus m2 square minus 4 plus 2 becomes a minus 2. So there is m1 minus m2 bracket square, right? So value m1 minus m2 bracket square is, what is m1 plus m2? 2x1 y1 upon x1 square minus a square bracket square minus 4 into, what is m1 m2? y1 square minus a square upon x1 square minus a square. Just now we have seen that is. Simplify. x1 square minus a square bracket square is LCM. So therefore 2x1 y1 square minus 4 into bracket y1 square x1 square minus a square, because there is only one x1 square minus a square, x1 minus a square bracket square is LCM. So x1 square minus a square into y1 square minus a square, and therefore this is m1 minus m2 bracket square. Now m1 minus m2 is equal to c given. So I have written m1 minus m2 bracket square is equal to c square. So 4x1 square y1 square value minus 4 into x1 square minus a square y1 square minus a square equal to c square. Replace x1 y1 by xy. Get the, whatever they ask you, that substitute the value of m1 plus m2 m1 m2, right? And get your locus, whatever you want. That is third one. Cot theta 1 plus cot theta 2 is equal to 5. That is 1 upon tan theta 1 plus 1 upon tan theta 2 is equal to 5. That is a tan theta 2 plus tan theta 1 upon tan theta 1 tan theta 2 is equal to 5. What is that? m1 plus m2 is equal to 5 times m1 m2. That is m1 m2. So 2x1 y1 upon x1 square minus a square, that is m1 plus m2 is equal to 5 into m1 m2 y1 square minus a square upon x1 square minus a square. It is cancelled. So 2xy is equal to 5 into bracket y square minus a square. I showed you some important locus there. 1 upon cot theta 1 upon cot theta 2 is equal to 3. That is nothing but the tan theta 1 plus tan theta 2 is equal to 3. That is m1 plus m2 is equal to 3. So 2x1 y1 upon x1 square minus a square is equal to 3. So 2x1 y1 is equal to 3 into bracket x1 square minus a square. 2xy is equal to 3 into x square minus a square required locus. I have shown that with the help of only y is equal to mx plus c, how many types of locus we can calculate. That is not only for the circle, it is for the parabola also. It is for the ellipse also, hyperbola also, right? So this is shown for the standard circle. Now turn for the general circle. Show that 3x plus 4y minus 36 equal to 0 is a tangent to the circle. This is a circle. Find the point of contact. Listen here, what I have done. Here is no condition. First of all, equation of circle is given there. X square plus y square minus 2x minus 4y minus 20 equals 0. Be careful about it. Coefficient of x square equal to coefficient of y square must be equal to 1. Then you find minus g minus f. Half the coefficient of x and opposite, half the coefficient of y and opposite. So center is minus g minus f is 1, 2 here. 1 opposite half, that is 1, 2. So radius equal to root of g square plus f square minus c. That's a root of minus 1 square plus minus 2 square minus 20. So root 25, that is 5 is a radius. We have obtained the radius, we have obtained the center. Now we are going to find, we shall draw the perpendicular from this line on this line from the center. Listen here. This is draw perpendicular from center on the line 3x plus 4y minus 36 equal to 0, right? So length of the perpendicular formula, ax1 plus by1 plus c upon root of a square plus b square. Only in the equation substitute their x and y as a minus g minus a. So 3 into 1 plus 4 into 2 because center is 1, 2. So G is 1, F is 2 minus 36 upon root of 9 plus 16. So mod of 11 minus 36 upon 5. A mod of minus 25 upon 5 is equal to 5 units, which is equal to radius of circle. That way, a perpendicular drawn from center of a circle to the line is equal to radius. Obviously, the line must be the tangent. That is, therefore, 3x plus 4y minus 36 equal to 0 is a tangent to the circle. I have shown for the general circle also to find the point of contact. So this is the center. This is the line which becomes a tangent now. What to do? P is a point of the contact. P is point of contact. Let PHK, okay, coordinate. Slope of CP, CP perpendicular to the line. So CP is equal to minus 1 upon slope of this line, reciprocal opposite. So that's equal to, its slope is minus 3 upon 4. So its perpendicular line is 4 upon 3. So 4 upon 3 is the slope of CP. So equation of CP become y minus y1 is equal to m into bracket x minus x1. Y minus 2 is equal to slope 4 by 3 x minus 1. So you can obtain the equation of CP like this. CP. Now equation of CP and equation of this tangent, you solve it. Solving the equation 3x plus 4y 36, 4x minus 3y equal to minus 2. Solve yourself. You know that you can use the Cramer's rule. You can use any simultaneous method. In your 10th standard, you can find the value of x and y. So x equal to 4 and y is equal to 6. The point of contact is 4, 6. I not solved. It is left to you. You can solve this equation very easily. So it is for the general circle. That what I have given you the information that I have totally satisfied with the help of this. So you see that a particular line is given to show it is a tangent. What to do? What we have done first? We have found the radius center. Then we have drawn the perpendicular from center on the line. And if it is equal to the radius, line becomes a tangent. Once becomes a tangent, there I have shown. So CP join it. So slope of line, tangent, reciprocal opposite CP, perpendicular. So once the slope of CP is known, point is known, slope point form, write the equation, get the equation of CP, solve the equation of CP and this line, get the point of contact. Correct? So this is a point of contact. Now find the equation of tangent to the circle x square plus y square equals 16, which is a parallel to the line, which is parallel to the line. Which type of circle is that? Standard circle. Slope of the line x minus 2y plus 5 is equal to 0 is slope that is equal to slope of tangent because slopes of parallel lines are same. What is the slope? Minus 1 upon minus 2. Minus 1 upon minus 2 is 1 by 2. So m is known. It is a standard circle. It is a standard. Y is equal to mx plus c. C is equal to plus or minus root of a square m square plus a square. What is a square here? 16 into what is the m? 1 by 2. 1 by 2 square plus a square 16 plus or minus root of 16 into 1 by 4 plus 16. 4 4s are root 20. So C is equal to plus or minus root 20. Substitute here. Y is equal to mx plus c. Y is equal to 1 by 2x plus or minus root 20. Simplify. Get these two equations. These are the two tangents because the point is outside. So two tangents can be drawn. Remember that. Remember that it is, there may possibility that not only the slopes are given, they may, you ask, find the equation of tangents drawn through outside the point to the circle. In that case, what we'll do? Y is equal to mx plus c. Coordinates satisfy the equation. Coordinates satisfy the equation. Say for example 2, 3. 3 is equal to 2m plus c. So in that case, you find the relation between c and f. C in terms of m. And then take this line, write, if it is a tangent, its distance from the center is equal to radius compare, so that you will find the two values of c or m. If you find the value from there m, you get the c, right? If you find the value of c there, you get 2m. So in this way, the point outside the given is there. Only coordinates satisfy the equation. Take the line, correct? Coordinates satisfy the equation. Get the relation between c and f there, c and m. So for example, 2x is equal to 3m to x, no, sorry. 2, 3 point is there outside the given, that is, for example, 2, 3. 3 is equal to 2m plus c. So therefore, 2m, write this, that is 2m minus 3 is equal to minus c. Oh, sorry, 3 minus 2m is equal to c. Find this value. And then you take the mx minus y plus c is a tangent. So draw the perpendicular, use the same formula, substitute the value of c in terms of m there, simplify it, get the two values of m, two corresponding values of c, right there. These are the two tangents. So these are the types they can share. Okay, next now. And the point of contact is given by or pair minus a square m upon c comma b a square upon c. Only substitute the value. A square is a 16, c has, that is, obtained plus or minus root 20. So therefore, once you take the root 20, then minus 20. So minus 4 upon root 5, 8 upon root 5, and 4 upon root 5 minus 8 upon root 5. These are the 2 points of contact. Two tangents are drawn. 2 points where they intersect, or we say that contact to the circle. So these are the 2 points. Okay, right. Now touching circles, number of common tangent, length of tangents, and radical axis. Right, this is a formation. Here you see that these are the 2 circles, intersecting circles. How you can find intersecting circles? So what will the condition for that? C1 C2 is a less than R1 plus R2, and C1 C2 is greater than more of R1 minus R2. The circle intersect in 2 distinct points. The circle intersects in each other in 2 distinct points. Number of common tangent drawn is equal to 2. Number of common tangent drawn, this is shown 2. And these 2 tangents are called direct tangent. These are called direct tangents. These are two. Direct tangents. If C1, C2 is equal to R1 plus R2, C1, C2 is equal to R1 plus R2, circles touch each other externally in that case, remember that. And then a P is a common point of contact. P divides C1, C2 internally. In that case, P divides C1, C2 internally in the ratio R1 as to R2. C1, C2 perpendicular, common tangent at their common point of contact. That is, the L line is perpendicular C1, C2. Total number of tangents drawn 1, 2, and 3 in case of touching circles externally. Now here, touching circles internally. So only one tangent is there, and the that is only, see that mod of C1, that's equal to mod of R1 minus R2 is equal to C1, C2. So this is MNN called direct. Yes, that is for this. So internal touching. Let us consider for this neither touching nor intersecting. See again the figure, if you want, you can listen here. So these are the circles, neither touching nor intersecting. So what we have? 1 tangent, 2 tangent, right? 3 tangent, and 4 tangents are there. That is the only case where circles neither touching nor intersecting. The 4 tangents are there. Out of them, 2 tangents, these 2 are called direct common tangents, and other 2 are simple only common tangents. Right? So for this we shall see that the process is what? First, C1, C2 must be distance is equal to mod of R1 minus R2. Circle touch each other internally, first of all. And in that case, the common point of contact P divides C1, C2 externally in the ratio R1 as to R2, just we have seen. And the only one common tangent is correct, for the internal touching, and that is for C1, C2 greater than R1 plus R2. C1, C2 greater than R1 plus R2, right, directly. No other condition. Circles neither intersecting nor touching, and number of common tangent drawn are 4 in numbers, and L and M are direct common tangents, right? Correct. Next. See that S is equal to, so it is, we say that, just a minute. Length of tangent. Length of tangent Px1y1 is a given point outside the circle. From point P, tangents are drawn to the circles which touches at point Q and R there. So S is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. Then length of tangent segment, that is PQ or PR, from point Px1y1 is root S1. What is S? S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. So root S1 means what? Root S1 is equal to root of x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Only, not equal to 0. Length is there. So PQ is equal to PR. As you know that a tangent segment drawn from outside point are always equal in length. Correct? That is also for standard circle, root S1 for any circle. Now turn to one more word that is called radical axis. What is a radical axis? Radical axis is a locus of points in the plane. Two circles are given, right? Radical axis are locus of points from where tangents drawn to circle are equal in length, right? It is a locus of points in the plane of given two circles from where tangents drawn to these two circles are equal in length. In above figure, 4 figures, last 4 figures that we see. For intersecting circles, a line containing common chord, for intersecting circle, line containing common chord is a radical axis. 2. For external touching circles, common tangent, that is common tangent like this, right? This is a common tangent. Common tangent at their common point of contact is a radical axis. Similarly, for the internal touching circles, right? In case of neither intersecting nor touching circles, a line perpendicular to C1, C2, that is center joining this that is segment, and a line perpendicularly, it is neither tangent, correct, nor secant, right? So C1, C2 is a radical axis. Equation of radical axis, S equal to 0 and S dash equal to 0 are given to circles. Let Px1, y1 be a point belongs to radical axis. So what is the length of the tangent drawn Px1, y1? Root S1. Here root S1 dash, and they are same for the radical axis. So root S1 is equal to root S1 dash. That means S1 is equal to S1 dash. Therefore, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal to x1 square plus y1 square plus 2g dash. Center changes. C dash x plus 2f dash y plus c dash is equal to 0. So equation becomes 2x1 into bracket g minus g dash plus 2y1 into bracket f minus f dash plus c minus c dash is equal to 0 is the equation of common tangent. That is a radical axis. Radical axis is a locus of points from where tangent drawn to the circle are equal in length. बेटा तुला करायचं आहे